Hey Eugene, how's it going?
Yeah, hi, Della. It's all good here.
Good,
Yeah.
good. I'm really excited to be introducing Eugene today. I found out that you have a PhD in computer science, so should I be calling you Dr. Petrenko or Eugene?
Well, it's something new to hear. So the Eugene works better, I guess. But it's up to you.
Sure. So Eugene is a developer on IntelliJ IDEA team. He's responsible for so many awesome features, including one of my favorite when I started getting to know IntelliJ IDEA, which is the JDK downloader. Um, I don't know why the other. I've used a lot of other IDEs, and the main one that I had was not. Didn't have this feature. So you'd start the IDE and it would just fail with an error because you don't have anything installed. So I was like, when I downloaded IntelliJ IDEA and it started, and I didn't have a JDK because it was a brand new system, and it asked me to download it. I was like, this is amazing. Like, why didn't we have this before? And then, I found out you wrote that feature, of course, with the rest of the team. And I'm like, I'm so grateful because I have so many times where I'm downloading like Java 15 and Java 16 and whatever. And just keeping up with that is difficult. So thank you, Eugene, for an awesome feature.
Yeah, you're welcome. It's great to hear that the feature is being used and helps everyone around.
Yeah,
Thank
it's
you.
awesome. Yeah, especially with the new rapid releases of Java, it's really helpful. So besides developing awesome features and being a trainer and a blogger, Eugene is also a jogger. When he visits new cities, he goes around and jogs like 12 kilometers in Sydney. Is that right? Wow,
Yeah, that
that's
was it. And it was so inspiring in that city. I started the jog and I just started looking around and then I realized, oh, it was 12 kilometers or 14. I don't remember exactly. It was so cool. And there's so many things to watch around, for example, in that city. And there are many other cities where I was. And it's so nice to
that's
match what I've
awesome.
seen while jogging to what you have in there, like in a tourist attractions list. And then comparing this, you see, oh, okay, 95% is done. Fair enough.
That is amazing. I'm just doing the Couch to 5K program right now, so I'm nowhere near jogging around in a city, but I can imagine that being just really great. Hopefully, you get the chance to do that again when we're traveling and we can go to places.
I hope so,
Um,
and it's a good habit to jog and see new cities where I've never been before. For example, I try my
yeah,
best in doing so, but
awesome.
these
That's
times it's a little bit harder.
Yeah, I mean, no matter what, I think it's awesome to combine two of your loves, seeing new places and jogging. So that's really great. So Eugenia's going to talk to us today about indexing. That's one thing that I really want to learn more about from an intelligence standpoint. I know it's the reason we get a lot of the awesome features that we have in IntelliJ IDEA. So I'm really looking forward to this session. Eugene is going to talk to us about how you can shorten your indexing time in your IDEA. I know that's something kind of a bottleneck for some folks. So I'm really looking forward to this session. So I'm going to hand it over to you, Eugene. Thank you very much for being here.
Yeah, thank you. So, yeah, now you probably see my slides. So hi everyone once again. So I'm Eugene, and I'm covering the indexing part of IntelliJ. And we'll touch on also the point where how we made indexing a little bit more faster in IntelliJ. But before we go, and since this is IntelliJ 20 birthday event, I would like to ask a question, but don't be worried. We covered the answer in the middle of this presentation. But just try to imagine how would find usages work. And interestingly and relatedly to the past, this was one of the first features which you may have seen in the renamer. Frankly, I haven't seen renamer myself. I was too young to try it, probably. And but nevertheless, this is the feature. This is the idea which was covered in the keynote of the yesterday from the yesterday. As for today, in IntelliJ, you may find the find usages, and it may look like this. And it may work like almost instantly. So you just click and you see some results. It works really fast. So I would ask you to think, how would you have implemented this one? While I'm talking some introduction, you may think about it, and we will take back on this. But now I would like to reflect on my past. And to be fair, I started doing programming probably before the renamer was released. And in my times, the program may look like this, or even in a tube monitor with a console mode. And in that times, we used to have no highlighting at all. It was the program. And to be fair, this version of Java had not yet existed. And so it was how we program. We can start a compiler, we can see the results, but it was, well, a little bit hard to see any errors in the programs before a compiler is executed or the program is started and so on, right? At some point, I've upgraded my environment. I got a better monitor and I got the simple syntax highlighting, like that one, for example. And it made the programming better for me. So I realized that, okay, I can see something more in this code. I can see some problems probably, but at least I can see what's going on in this program. It's better. And then we jumped and evolved into the smart inspections, highlighting what we have nowadays in IntelliJ. And then we see that, okay, there are so many troubles in the nice looking code snippet. And these troubles has to be fixed before it run. It wouldn't run actually. And to be fair, I made these mistakes on purpose. And now, thanks to highlighting and the code inspections, we can see the problems. We can see that the for loops are broken. We can see that there are some missing classes used, or what does this swapper story to mean? I have no idea. And the thing is that in editor, we have this hero highlighting, which shows up quite fast. We see that, okay, there is no such a symbol. What should we do? And how could IntelliJ do this that fast? To be fair, it's really related to find usages. So IntelliJ would try to find and see whether we have that symbol somewhere in the project, in the sources, or in the libraries. And if not, there is a highlight. If we do have it, it might be an import pop-up, by the way. Well, I decided to go for an experiment and to try on myself, how would it be to find a given symbol? I decided to go for an experiment with a full text search. So what we do, we grab IntelliJ codebase, like an example on a sort of medium to big project. It's on Apache 2 license. It's on a GitHub. It's not that long to download, 4.5 gigabytes. It's about 120,000 files, whereas it's about 77,000 files of Java reporting sources, which gives us around 200 megabytes of the code. Well, what we do, how would we search for a symbol in a file? Well, we can use the Linux, Unix, Mac standard tool, which is called fgrep. We just scan through the whole code base to figure out where is the file containing this string. No matter where the string is used, we at least have an estimate of the places where this class can be declared. Next, we have to go through the average of these files and filter out all the wrong results. Like, for example, this word can be used as a string, as a text, as a command, as a method name, or something else. We should filter this out, and then we can have all the usages, and then we can say, okay, fair enough. Now we have this class, and now we know, like, for example, the name, whether it exists or something else. Surprisingly, my experiment took time on macOS, 80 seconds. I don't know why it took 80 seconds. It's too slow. I don't know. Maybe my computer is broken. On the Linux machine, which is not the new Linux machine, by the way, it was 1.5 seconds, which is pretty good, wasn't it? At that point, I realized that something might be broken in my computer and I'm missing the Windows. But on the Windows, we have no standard fgrep. At least I don't know about this. Of course, there are so many tiny utilities which replace or does the same features as the fgrep, but it's not the case. It's not the standard. So I decided not to give it any of this a try. I decided to code a small program. This is written in Kotlin, but I guess you can see what does it means. It just uses their Neo2 APIs, it lists all the files, and it simply tries to read all the files from under the IntelliJ community checkout folder. And I measure the time, and I see I got the results. And this time, the results are better. What I see, what I have is that the time, it takes around 4 seconds on Windows, 2.5 seconds on macOS, and I decided not to even try it on Linux. There is no sense. It would be around 2 or 1 seconds anyways. This is pretty good. This is pretty fast. So to summarize, if I would need to find a given symbol somewhere in a codebase manually, I would spend several seconds at least to get the result estimate. And then I would need to spend more time to figure out which results are valid, which are not. This is not that fast to be true, because when I use the full text search in IntelliJ, usually it is able to figure out the results even faster than I type. That's the performance, that's the speed I like to have. And now I'd like to explain you what's the difference between our approach and the IntelliJ. And the thing is that behind the scenes, IntelliJ is using the Trigram index. The Trigram index is a specific data structure which helps to speed up the search. And in IntelliJ, it's implemented the most performant way. I will explain you just the idea how it works. It is enough for us to understand the thing in this presentation. Otherwise, it would take longer and be way more complicated. Well, to start with, the trigram or a triplets or 3-character sequences. So what it does, it takes the string, say swapper32 as an input. It cuts it on all possible 3 characters by like moving a window, 3 next standing characters. It takes all these characters, so it creates all the possible triplets or trigrams. Then it uses a database of all the trigrams. It goes through, it looks into their variants, and from the database, we can know in which files we've seen each of these trigrams. Of course, it's not the answer yet. We need to like intersect all the files because we will need to consider only the files which do contain all the trigrams. So we do the intersect, and now we have an answer. And of course, before we give a file as an answer, we have to prove that it indeed contains the exact string we've been looking for, not all the trigrams, because having all trigrams is a high probability of having the original string included, but it's not the guarantee. There could be the files which do contain all the trigrams, but in different places, not forming the same string as we started to look from. And by the way, the full text search in IntelliJ is able to do the search with the regex, regular expressions. And it uses the trigram for implementing the regular expressions for your search as well. Well, but I've been talking about some database with you now. And as long as we have this database, we need to spend some time preparing for the search. This is what we need to do to make it answer your questions really fast, to make IntelliJ work for you really fast. And this is called like building of indexes or indexing. And what we do in this particular example, we take every file in a project. We not only take in the sources, but also considering the parts of the library, say the sources from a library, or even the classes for specific indexes. And we extract all the trigrams, and we create the data in a database for a file to trigrams. And then we create in a so-called inverted index, so we, for every trigram, we know in which files we've seen it. And this is the thing we need to prepare for the work, for the search. To be fair, like the document search systems or databases, they do spend their time on indexing as well. And so that in this example, what we have a file as an input. We cut it into a trigram, and this information is stored in our indexing database. And this and other indexes are being built when IntelliJ is showing this progress for you, like updating indexes. This is what is happening underneath. This is why we need it, because this is the way IntelliJ gets smarter and knows what you have in your codebase, so that it could answer you almost instantly on most of your questions. Like, for example, the name search, the class name search. When I type the class name or only the capital letters of the class name, I see the result, again, almost instantly. And to be able to navigate me from a class name to a file in my project, we do need to build this index of class names. It's not the trigram index, it's a different index, which IntelliJ has to solve this particular problem. And speaking about the find usages, the implementation of that one uses another index. It's called ID index. The ID index or identifier index is a really tricky thing. But no, I'm joking. It's not that tricky. It's the list of all identifiers which we have in all the source files in our project, including libraries, and in all languages. It could be Java, it could be Kotlin, it could be Python, JavaScript, whichever you like, whichever you use. And this is a huge set of information. So when I'm looking for identifier, I jump into this index, and now I know all the files where this word is used as an identifier, not just a string, but as an identifier. So it's quite a few files. Then for every file, I have to go and check if it is the right usage of my identifier or not. For example, we may have the swappers 32 declared in JavaScript, in Java, and maybe in C++. These are three different declarations. This would work. So we need to process all the found files to figure out which are the really matches to what I've been looking for. Maybe we can do the go-to declaration and make sure that both the original one, from which I do the search, and the found one, they have the same declaration together, or maybe something different. But this part, again, is a language-specific part, but it uses indexes underneath to do the job. So the rename refactoring is built on top of the find usages. That's yet another example. At the moment where we can find all the usages, we can replace these usages with the new names. Just fix some imports probably, maybe reformat the code a little bit, and the work is done. Again, this is based on top of indexes through the find usages in this example. And there are too many places in IntelliJ where indexes find place, like import pop-up, like find usages which we covered, some navigations, inspections, and highlighting. For example, the nullability things in Java is partially using indexes to highlight you some problems, and so on. Of course, refactorings do use indexes, and so that's an endless list. I can answer probably yet another question for you. So how many indexes are there? I've made this test in IntelliJ 2021.1 EIP, and I figured out that in IntelliJ Ultimate, that's around 208 indexes included. In IntelliJ Community, it's 99. So why the difference? Because the number of indexes do depend on the number of classes or number of plugins which we have included or enabled in our IDE. So for example, for my daily work, in my IntelliJ Ultimate, I have around 155 indexes. That's because I turn off some plugins. And the same thing can happen to you. So you may have a different plugins or additional plugins, and the number of actual indexes may be different. That is it. So, and here comes a horrible thing. It is true that indexing can be slow, unfortunately, but it is true, and we know about this. The good thing that we are trying to make indexing faster and faster, release from release. We keep working on this. Well, the second sour thing here is that indexing is done per IDE instance. So if I open my IDE with a project, I do indexing. If you would open the same project with the same IDE, you would have the same indexing running for you once again, and so on. That's sort of a time waste, isn't it? And out of the statistics, I would say that we do spend, as a whole community of the users who's using IntelliJ Ultimate or Community Editions, we spend around the human years per week on indexing. That's the number. And we decided to come up with another approach to make indexing consume less time for the whole world and the whole community. That's called shared indexes. And I'll be speaking about shared indexes with you now. So the shared indexes is the idea that we are able to literally share indexes. So I mean that we would use the pre-computed data from one place in other IDEs. So there should be multiple IDE instances that would use the data instead of computing this data, or instead of building these indexes. So for example, with the Trigram index, we would be able to download this database from somewhere and use it instead of building this locally. And you may remember that in that example, I've been referring to a file, a mapping between a trigram and a file. Here, when we're trying to share an index, we can no longer use file because a file may have a different path, for example, on Windows or on Unix, It could be different. The file may have a different line length inside, surprise. Or even I and you may have a different files, right? Because I have one revision and someone else has local changes. So to overcome these limitations, we came up with a specific hash function for file content. So now we consider, on an example for trigram index again, we download the index, which is the mapping from a trigram, into hashes. And when we do a lookup, we do have the hashes as the answer. Then we try to figure out if a given hash has a local file on my machine, which refers to it. If there is such a file, then we can grab that file and go further and process the results. Of course, it can be the situation where for a given hash, there is no file on my computer. Say, for example, I remove that file or change that file. That's all fine. That's okay. Because the shared index is not the one index which is used. In fact, it's a combined structure. So when I have the IntelliJ running or IntelliJ-based IDEA running, it uses the local indexes, it uses the shared indexes together with the local indexes to answer my queries. On a trigram example, it would be like this. We query, for every trigram, we query a local index and the shared index. And then from the shared index, we have the hashes, we map the hashes to the files, and then we have the files so we can continue the processing of this data. And by the way, I forgot to mention that on the previous slide, is that the mapping within a file and the hash, or a hash to a file, that's two-side mapping. We build this mapping locally on every computer, and we maintain this index. This index helps us to be able to use the shared index, which is download. So we spend less time building this index. That's the main trick. So, and of course, we still need to build this index, but now we do this only once for a number of machines. And for the building, it's essentially the same as it was before, but instead of recording the mapping between the file and the trigrams, we store the mapping between a trigram and a hash of this file, which was computed by this algorithm. That's the difference. And that allows us to share indexes. So speaking about indexing, the shared indexes would not replace the indexing progress and indexing task. Instead, it makes indexing work faster. This is the main achievement that we have. So I would like to explain what shared indexes allows us to do. The first thing, to use indexes, just similar to what I've shown before in the previous slides. So we either have the bundled shared index, like you download IntelliJ, and it comes with the bundled pre-built shared indexes for JavaScript. It helps to spin up faster for most of the projects. Or IntelliJ may spin up, figure out that you're, for example, using a JDK, and then it would download the JDK shared index for you so that it would be faster. So it is able to use a bundled indexes, or it is able to use a downloaded shared index. This, by the way, applies not only for IntelliJ IDEA, but for all IntelliJ-based items. The next thing we have a logic in this subsystem to figure out the best suitable shared index in the network, be this a public CDN or be this on-premises CDN or location. It is able to figure out the best suitable shared index and download that and use it. And lastly, of course, there is a tooling which allows us to build shared index on a project or on a library or on a JDK and so on. And this tool is a headless. It is operation system independent, which is by itself tricky. A command line tool, which you may spin up and get the index built in your case. So I mentioned that there is one IDE and there is a shared index built by something else, right? And of course, there is a question of the compatibility. How these two are compatible? So the first off, we have a base version. That's similar to base version for the local indexes. That's the most specific constants which define if a given IntelliJ is able to read the data. So this is a prerequisite for a shared index to be loaded. But then we have a later compatibility check. I mean that as long as we are able to open the storage, we check their compatibility between the plugin, between the indexes independently. So I mean, there could be an index which is included in a shared index, and I may have on my ID a new version of another index, which is not included because, for example, it's just not included in the shared index, or it can be of another version of my shared index. That's all fine. This data would be recomputed locally on my machine. So essentially, it would be like a two-dimensional graph of it, because on one axis, we would have their indexer versions. The other one, we would have the files. So it could be a file being changed so that we would need to re-index that file with all the indexers, or it could be an indexer version change. Then it means that we would need to reindex all the files with that indexer, but with only one indexer. And the main speed up comes from the point where we don't need to re-index with all indexers a given files. So remember, I've shown you in IntelliJ Ultimate, it's around 200 indexes. That's too much. That's pretty much. And this is the reason how we can minimize the time spent. And should it be a little bit different on my local machine, maybe I've installed a different plugins or removed some plugins or I updated the plugin, that's no problem. All the difference would be computed locally. So it will just run. Speaking about the shared indexes, we realized at JetBrains that it makes sense to share this approach to the community. So for now, we are building shared indexes for everyone. This includes the JDK indexes for the recent JDK releases, like just the releases you may see in the JDK downloader. We build the shared indexes for Maven libraries to speed up their project indexing on the popular libraries, which are likely to be used by almost everyone. And we do help to improve their indexing time for IntelliJ SDK users. If you are creating your IntelliJ plugin, the indexing will be faster for you as well. And of course, there are more public shared indexes to come. Stay tuned. Well, as for building shared indexes, there is yet another computational problem which we solved. Because there are a number of IntelliJ versions which we would like to cover. This is the releases starting from 2020.3. These are EAP builds of 2020.3 and newer. But as for EAP builds, you know, the EAP builds, their lifetime is limited in 30 days. So we only having the shared indexes for EAP builds for the 30 days. We are not building the indexes for an older IDs, which would never start. And internally at JetBrains, we do test and we do use our tools so that we include the shared indexes for internal nightly builds of IntelliJ, for example. This helps us to see if it works, how it works, and what could we improve. As for building, so we build the public shared indexes and the internal shared indexes. As for internal, for example, we do build shared indexes for IntelliJ Ultimate project to help ourselves run better. And as for building, we use TeamCity because we have thousands of tasks to be executed. And as long as we support the nightly builds, the number of tasks is growing. So this is how we build it. And as for distribution, we have the CDN. So for the public shared indexes, we have a public CDN, which has around 700 gigabytes of data so far. And we're constantly updating and uploading the data to the CDN for newer builds of IntelliJ or for, say, for newer releases of a JDK and so on. As for the protocol, IntelliJ and shared indexes, they use HTTP stateless protocol between the IDE and their CDN. We don't need any server-side logic, which makes it easier to spin up the whole world CDN for every one of us. And as for project shared indexes, remember I've just mentioned that we're building it for IntelliJ Ultimate. What is this? This is a way to maximize the effect of shared indexes in your case. So you build an indexes for your particular project, including all your libraries, all your sources, and so on. And it helps to faster the clean indexing time. It helps to faster the branch switching. But you should understand that the actual performance improvement, and I'll show you more graphs in a moment, it may depend on many factors, including the project, the languages, the network, and so on. So it should be a good idea to measure what you would have on these examples. But if it works good enough, then every team member would have the benefit of a shorter indexing time. And as I mentioned, we use HTTP and so HTTPS, and so it's The solution is on premises ready, so you may spin up it inside, or it's a cloud ready, depending on what you would like. But the setup is not that easy. That's something we know so far, and I think we may come up with something different on this. So technically, that might look like this. So we have a version control in the middle. We spin up the indexing jobs to generate the indexes. We upload this data to their CDN. And IntelliJ IDEA or any other IntelliJ-based IDE downloads the necessary indexes if it needs these indexes. Usually, IDE downloads indexes once and waits for some time because this index is good enough and there is no need to re-download it in the nearest future. That is it. So I mentioned about experiments. And now I'm happy to share the metrics or the measurements which I've made. The first thing, and by the way, I'll explain you a little bit more data information on the JDK indexes, for example. So here's the problem. You have an IntelliJ project. You open this up, and it uses some SDKs, the JDKs inside. And we need to match this JDK to a shared index. How would we do this? The first thing what IntelliJ does is it computes the hash code of the JDK contents, and it looks in the CDN if there is a shared index with this hash. If there is such an index, the index will be downloaded and the indexing would run faster. It could be the different situation where the hashes would not match. Remember, I told you about the two-dimensional graph of the compatibility. It is not the problem if we would download a slightly different shared index for your JDK. So we use the JDK name and versions to try to find something like similar. And if we would do so, it would speed up the indexing for you as well. As for the generation of the public JDK shared indexes, we actually use the same data as we have behind the JDK downloader dialog. Have you ever tried this dialog, by the way, in IntelliJ? So for this dialog, to keep up with updating Java versions, we do have a backend. We have a service at JetBrains where we list all the actual versions of all the JDK. So when there is a new JDK, the dialog will show it to you no matter how old IntelliJ is. And the same data is fed into their generation tasks for shared indexes. So when you, for example, downloading the JDK with the dialog, their compatible shared index is downloaded in parallel with the JDK download. This is how we try to make it work faster for you. And here's an example. I've tried to use an empty project, clean indexing in Amazon Corretto. In my example, I have the shared indexes downloaded, pre-download. So that's sort of the best expected time which you may expect. And in this case, it's 37% or 10 seconds less indexing time was needed to spin up this project. I do really like this result. Well, speaking about the Maven libraries, as of now, we have a list of 123 libraries which we index. When we do index a library, we do include all the transitive dependencies, because once again, the chances are quite high that everyone who using the library would use like the same dependencies or like a similar versions of these dependencies. And when IntelliJ does a lookup, we do first try to look up with a full name of the library, like JUnit 412. If there is an index for this library, then it is downloaded and it's the best performant situation. There could be another case where there is no index for particular this version, so that we would try to find an index for a major version. Usually, when you have a minor update in the library, it would not change the whole library, hopefully, right? So the chances are that the downloaded shared index would be a good match anyways, no matter if it has a little different between some slight changes. So I made an experiment on an IntelliJ plugin SDK project. So we have an amazing Gradle plugin template on a GitHub. So if you would start doing the IntelliJ plugin, it could be every IntelliJ by step IDE, by the way. And there is a Gradle plugin. It do the heavy lifting for you. So you only would need to write some code. And there is a template on a GitHub which would help to start the project for you. So the indexing time in this example was 64% less. So I'm really happy to see that everyone who would be doing the shared indexes, sorry, a plugin for IntelliJ would spend that less time on their like start experience. So if you have like a passion or a flow in doing the plugin, now it would be faster for you to spin this up and have first experiments. Well, here's the trick. We do build the public shared indexes for IntelliJ community project. So if you have this plugin included in your IDE, you might open IntelliJ community project sources, and you may experience how faster it gets the indexing in this example. On my machine, and remember a grep example, right? On my macOS machine, it took 51% less time. Maybe it's something wrong with my machine, but it's a good result, and I do like it. And if you would give it a try, you may see something like this in the event log. It would show you information if some shared index was downloaded, and then it would write you an information on how many files were found in a shared index. Remember this two-dimensional graph. It would show you a projection on one side. So it would say you, okay, 82% of the files on your computer, on your project, were covered by shared index. That's a pretty good result. And I have a pretty good low indexing time in this example as well. As for IntelliJ Ultimate project, the thing which I use daily, we also have about 52% on my macOS. Not that bad. Well, that were only the numbers, that were only random numbers or like experiment numbers which I had on my computer. All the experiments I've done, these numbers were quite comparable. But of course, it may depend on my computer, on measurement, on too many factors. So to make sure that it's not getting broken and it's getting better, we have a well-established setup, continuous integration setup, if you will, which helps us to measure how this improvement differs or deviates from the time. So in this experiment, we have a specific hardware machines, the fixed machines for Windows, Linux, and Mac. These machines are dedicated for this task, and we do the measuring of shared indexes as follows. We have a build of IntelliJ, like a nightly build. We build shared indexes locally. Then we measure how much time would it take to generate index a project with no shared indexes enabled. Then we measure the time it took to index a project with the shared indexes enabled. And we can compare these times and we can see the results. And in our case, we spin up this test after every new build of IntelliJ is built. So we have a number of data, and here's the data as I have it. So every point in this graph is yet another build of IntelliJ. Every line denotes a different operation system. And their time, their vertical axis, is the percentage how fast their indexes turn out to be. The same measure as we had before, like 55% faster and so on. So blindly speaking, out of this data, we may see that their JDK indexing may improve their JDK shared index, may improve your indexing time from, well, at least 30% to say 50%. Well, it depends on operation systems. It depends on their on a build, but this is something we can see out of this data, and we're trying to analyze this data, and we're trying to fix it if there is some problems. Here's the graph for IntelliJ Ultimate Indexing, and here we can see that, well, in general, if you're using, say, Mac or Linux, we can expect 55 to 65% less time, even more than 65 if you're lucky. Indexing, this is pretty amazing, isn't it? Well, but you may probably thinking, oh wow, the graph, but why is so noisy? Why this data is so noisy? Well, the answer could be, well, probably you should not trust this data, or trust this data, but take the assumptions that we have. Well, here are some assumptions, and here are some factors which may affect this data. And of course, the first thing, the indexing process is not that trivial. It deals with the operation system. It reads the files on the disk, it scans it, and it may be bound with an I/O performance. The network performance, which is not even included in this graph, in my graphs, when a shared index is being downloaded, it may take time. And the longer the download takes, the less results, the less benefits it brings. So it should be like faster. But for example, in a JDK, the shared index is about 30 megabytes. It's not big. For a huge project like IntelliJ Ultimate, it may be around 600 megabytes. The dependency resolution time, speaking about the network, if I open a project for the first time, it may take time for dependency resolution. And this is something which has to be done before we're able to index or see if something is included in the shared index. It's again a problem. It depends on the enabled plugins. It depends on the number of files, either in the libraries or in a project. It depends on the languages which are used in the project. So it's better to give it a try. It's better to measure what we have. And now we come to the question, how can you try shared indexes, if you would? Well, there are several things which you can consider. The first one, if you're using the Qt New IntelliJ Ultimate, you're likely to be trying shared indexes or using that just out of the box. Starting from 2020.3, with JavaScript and a Go, shared indexes are bundled into IntelliJ. This is a common subset of indexes which helps for the generic case. And starting from 2021.1, we do include more, the PHP and the Python. This is what you actually do have now, and I hope this increases the performance of the indexing on your cases. The more thing you could try is to download the JDK or Maven shared indexes, as I explained it before. You may have seen this pop up in IDEA. Out of the data, it's probably 1/5 of you have seen this before. I'm not sure how many of you are allowed it to download something. It's up to you. If you are uncertain on this, just go to the settings or preferences that under tools, shared indexes, we do have the options where you may see your consents, whether you are allowed it to download something or not. Or you may change your mind every time you like. It's in the settings. When you change it, it will attempt to download the shared indexes for you, for your project, and so on. According to the CDN usages data, we can see that it's being used. It's being used by you and by others, but don't be worried. Once a shared index is downloaded, it would be kept in your IntelliJ. So it will not re-download the indexes instantly or really frequently. So there is nothing to worry about. And if you would like to give it a try with the project shared indexes, here's the way. You may use this action in IntelliJ, but you should have the project shared indexes plugin installed in 2021. Well, it would show you the action so you can dump a project shared indexes for your specific case. And then if you would follow these instructions, you might give it a try and try to see how fast it works when you load the shared index into your project. And you hope it would be a good enough improvement for you to consider trying this any further and setting up the generation pipeline as I showed you in the middle of the presentation. Well, now I would like to stop by and a little bit explain how shared indexes are available in the IntelliJ platform or in IntelliJ-based IDEs, including IntelliJ IDEA, of course. The first thing is naming. And we all know naming is hard. So we start experimenting with shared indexes. We named that shared indexes. This plugin appeared in 2020.2, in 2020.3, and before we name it, as I say, shared indexes, this plugin supports the bundled shared indexes, mostly for JavaScript and Go. It supports downloadable shared indexes like JDK, Maven, and so on, and the project shared indexes if you can set this up for your case. This is all done within the same plugin. In 2021.1, this is a IP so far, we decided to make it easier for you. So we decided to put the bundled and a public shared indexes support just inside IntelliJ. So there is no plugin anymore. It's just included in their IDE. It's included in all IDEs we built. And we cut the rest. We renamed it now the project shared indexes. This as a preview plugin, which helps to deal with their on-premises project indexes and it supports the tasks to generate this headless generation of their project indexes. This is a part of the project indexes plugin now. I hope this would make any reason and simplify the way you use it. As for IntelliJ, let's specify it more clearly. In 2020.3, the plugin is available on the JetBrains marketplace for the plugins. Just go in the plugins and install it. In 2021.1 EIP, in IntelliJ community, you would have the core part just included. And if you would like to give it a try with the project shared indexes, you would need to download the plugin from the marketplace. That is it. It's way more simplified in IntelliJ Ultimate. There we have anything included, starting from 2020.2, if I'm not mistaken. So 2020.3 and 2021.1, they both have anything included out of the box. It just works for you. So if you would like to give it an experiment, it's in there. Nothing needs to be installed additionally. As for other IDEs based on IntelliJ platform, yeah, it is possible. The shared indexes plugin is available on the marketplace for 2020.3, and we do have some IDEs where we do bundle it. Even more, in 2021.1, we have the same core, which is included to every plugins, and we have their project shared indexes, which is bundled in the most of IDEs. For the others, it's downloadable from the marketplace. That is it. This is how it is as of naming or availability, if you would like to give it a try. So to summarize, and that was our story on how we made indexes shared, and I hope fast. So with the shared indexes plugin, it's supposed that indexing would complete faster. And out of my data, I can say, well, it is highly likely that the indexing would indeed complete faster. But if it's not, well, let's debug it. This is all about software engineering, isn't it? So that was it from my side. And I hope it was interesting. Thank you.
It was. We have a lot of good comments from the audience, the awesome audience, that you did a really good job explaining a complex topic simply. So everyone is appreciative of that. It was very interesting. So we do have some questions. Most of them got answered by the moderators. So thank you, moderators, for that. One that was left was, did you try to share indexes in the cloud?
Essentially, we do. As I mentioned, the public CDN, it's actually cloud. So we use the CDN. In this case, it's Amazon. And we upload the data into S3, and it's available for around the world. Moreover, for the JetBrains internal use, we do use like a similar setup, but with authorization, so that only we can see these indexes, because indexes like the trigrams, for example, they don't contain the data as it is, but it's probably possible to extract some useful from your sources if you leak your shared indexes, for example, outside. So it's better to keep it protected if you are building the project shared indexes, like we do, for example.
I was wondering about that. Like, it probably has some things you want to protect that's specific to your source. So I would think that you want to kind of be careful with it.
Oh yeah. You know, like for example, if you have a beans of coffee, right? These beans, we say that's the sources, and we're like trying to protect this. Then you use a grinder, you put these beans in a grinder, and the result is something like a shared index, right? This is a powder. And if you're picky enough, you can rebuild the beans out of it, right? And that's the kind of analogy we have here. So if someone would really dig inside there, for example, the class names should be found easily, and so on. That's why it's better to not to share the shared indexes outside. That's in like a binaries, for example. But it's very far from binaries, but yet not.
Yeah, you can decompile or do whatever, but you probably want to be careful with your indexes. So that's really interesting. I've actually in the past used search in other IDs as my break time. And when I first started using IntelliJ, I was like, okay, I'm going to do a search, getting ready to get up and take the break. And it just came up and I'm like, why did this just happen? But I did notice that there's this concept of indexing that was happening when I started my IntelliJ, and it did take some time. So that's when I take my break. But I was appreciative that it's just one time operation. That after that I can search in my repo and not have to wait forever. So I can kind of tell that it's probably a very difficult thing to shorten the time of. What's the biggest bottleneck? Like what is, if you could solve this problem, it would shorten the time a lot?
Well, the indexing is not that easy, to be fair, because the first thing, you open an IntelliJ and should understand what are the new files, what are the old files on the disk. You may have changed it for some reason without IntelliJ noticing this, right? Then essentially it has to go through every file to see, is it the same or it's not? It has to go through all the libraries and see what's going on in there as well. Once we have this, we need to, for example, parse every file to build the PSI for every file to extract the data that we would need for the indexes underneath. So once we all do all these things, then we have it ready. On the other side, we try to allow some actions to work in a semi-complete indexes. It helps for you to do something, not anything, but something at least, while indexing is still running. So speaking about what we can improve, we may use the shared indexes. We may try to avoid checking all the files on the disk if we can for some reason, like using the file watching or like checking the library. If we know if the library is unchanged, we don't need to check all the files inside this. So we have a number of optimizations which we might take place in the future to have this work faster. And it's an ongoing process. There are so many things inside.
Yeah, that's amazing. And another question was, shared indexes seem like quite an obvious thing in retrospect. Is it something that the team had wanted to do for ages but haven't really been able to, or is it something that simply just was obvious that you wanted to implement?
Well, it's not that brand new thing. I guess there are several years at least. There are like so many things which we finally figured out and decided on to make it available, because it's a really huge topic. And from the huge ideas and the huge experiments to something which we may call the product, that's a long way. And we figured out the subset which we are happy to share so far. And this was a really long journey. On the other side, IntelliJ is really huge. And remember, there is hundreds of different indexes which are written already. And including the shared indexing in this should not break like hundreds of indexes. So it has to be done really carefully. Having all together, this is the reason it took some time for us to come up with something stable to try.
Cool. There's some other questions that just came in. Do you have recommended settings for slowish internet with data limits?
With data limits?
Yeah, I think they're worried about downloading too many things. So if you're downloading a lot of shared indexes or anything like that, is there any recommendation from that perspective?
Well, if you're speaking about the JDK indexes, it's around 30 megabytes per JDK. If it is downloaded, roughly pure IntelliJ version, there could be the versions of IntelliJ which have the same shared index. I mean, if it's downloaded once, it's likely to survive the updates in the next AP builds and so. On the other hand, if you really care about the traffic, you may not say always download in the pop-up. You may rather say download it once. This is the way you'll be notified on every attempt for every download. I hope it would help.
Okay. Is it possible to use Nexus Remote Proxy?
So essentially, IntelliJ uses HTTP server, like any static HTTP server or HTTPS, if you will, for shared indexes storage. So if you could make the Nexus the HTTPS server, like proxy or like HTTP server, that would be all fine. I'm not sure so actually we don't need anything beyond. That's it.
Have you had other approaches than triplets? how slower are they?
Well, it's good. It's good. It's a good question. I'm not sure. I know the whole story here. I guess that's their instead of triplets, you may have B or two characters thing. It would have like more results which are not which we would have to filter out. Like having 4 instead of 3 will increase the size we need on the disk for this data structure. So, well, we may probably take this offline and there find some more detailed answer. I'm just guessing the answer here.
Yeah, definitely. The chat is up, so we can definitely follow up on that. Have technology improvements helped improve indexing? I guess speed and memory, but also the cloud.
Well, I'm not sure about the cloud. Probably we'll cover it answering about the CDN. As for technology, well, yes, for example, SSDs, they do change the way how you use I/O. For example, now I/O is parallelized. We are using it and we are working on using it more because, well, there are some, IntelliJ is quite old project and there are so many things inside and some places we may improve and we are knowing about that and we're thinking and we're doing something to make it work even faster on the new hardware.
Awesome. I think that's mostly the questions we have. The last question I had for you was, I was actually really curious about implementing the JDK downloader feature. So could you tell us kind of how hard that was? Was it something that you've always wanted to do? And then you finally got the time to do it, or how did that go?
Well, it was like a small feature. I was suggested to do this feature you can do it like in several days. It looked to me like it was like a really short one. So I started thinking on it and I realized quickly that, you need to have the list of the JDKs somewhere outside of the IntelliJ because I may have an IntelliJ and then after it's released, we may have a new JDK showing up. And I, as a user, I would be happy to have this JDK listed in my downloader, right? So that was the first tricky thing. So I separated this part. So I have the list of JDKs on the JetBrains.com, and IntelliJ downloads the list for you, and then it shows all the data. So the list contains all the necessary data for you to download the JDK, to check the checksums, to extract it, and so on. This is the first tricky thing. And then it turned out that I realized, as long as we can download the JDK, why wouldn't we set the project up? Say I'm opening a project and it's missing a JDK. Could IntelliJ be so smart to find the JDK on the disk or to suggest me downloading a JDK for my project? And that was a really long journey. It was so exciting. I was so excited that we figured out how we can do this, and we indeed do this for the set of use cases. So now, for example, opening an IntelliJ community project on a clean machine, we just say, you need the JDK. Would you like to download? Yes, please. Here you go. And I do really like this approach. I do like that IDE does not force us to do some manual work, or when we open a project, say in a team, the project just opens and just works without any manual setup, which has to be done for every newcomers and so on.
Yeah,
and we're
exactly.
trying to avoid this. So overall, it made a really long journey in this case.
Yeah, and I was thinking about that because I hadn't updated IntelliJ, but it came up with Java 15 as an option. So I wasn't really sure where it was getting it from. It makes sense that you're hosting that list somewhere else. Okay, that's awesome. Well, thank you so much. This was extremely interesting. I really appreciate you coming here and talking with us today, Eugene.
Yeah, thank you for having me.
Thank you.
The good ending of the Friday, I'm not sure which time zone it would be for our listeners.
Well, thank you very much. I appreciate you. Bye.
Yeah, bye-bye.